Oi, so you may have wondered with this series, you can't do GPU kernels, right? You don't have a GPU? Well, even if you don't have one, you don't actually need one. Newsflash, GPUs on the cloud are crazy, crazy, crazy cheap, and that's what I'm going to show you today. First off, you go use Google Colab, I guess, and those are free, but personally, I don't like Jupyter notebooks very much. And it's just annoying having to deal with a few reasons I don't like Google Colab. If you want to actually rent out a GPU on the internet, what you do instead, go to cloud-gpus.com, link in description, obviously, all links in description, obviously. And what it allows you to do is look at all of the services that provide cloud GPUs and their current prices per GPU. I don't know how updated it is or anything, honestly, I'm not very sure. You can select and deselect different GPUs and add them into here. It doesn't have everything, I don't think. It has the more common GPUs, and then you go and you find what provider you think is good. It also lists off credits, which I believe means when you make an account, they'll actually give you money to use towards it. And some of these actually have a lot of credits. But the one that I usually use is called Vast AI because it's crazy cheap. There are cheaper, I think, but on the day that I actually use this cloud GPU comparison the first time website, like when it's the first time, on that day, Vast AI was the cheapest. So that's just what I've been using by default kind of thing, right? So Vast AI, you got to make your own account and everything, put in your credit or debit card and get some credits right. And so you can see over here, I've got $4.30 built in. The way I am actually using Vast AI is such that it's so simple, it's actually absurd. It's so cheap, I mean, it's actually absurd. I think I spend less than $1 per day on Vast AI when I'm spending the entire day on Vast AI. Like I'm spending, let's actually look at it here. Let's just go see an example. So it lets you filter what GPUs you want to use. If you don't know what the heck you want, which is totally cool, let's do just what I filter by right now. So host, there's a bunch of stuff on the left here. Host reliability, higher is better, obviously. 99% is probably fine. That just means like how often will it disconnect on you and whatnot? Because these are, what makes Vast AI a bit weird is these GPUs are actually all over the world. I believe it is random people or random data centers with GPUs they want to sell plug into Vast AI. So it could be anybody's GPU is my vague impression of this. But therefore, the reliability varies. If you go to somewhere like Lambda, for example, I first used Lambda actually, which was because Andre Karpathy used it in his tutorial series, and I just didn't want to look around for something else. Lambda is a more expensive option, but also more reliable and more heavily featured, and has bigger, better GPUs available. But we're not going to Lambda today. We're going to just do Vast AI. So I would say go down to per GPU RAM, aka their DRAM, their HBM, right? And just do at least 16 gigabytes. I put it right below 16 just so I don't mess up. I don't know if it was inclusive or exclusive, but so 15.45, right? That's enough amount that you'd actually use for this tutorial series, obviously. All of the code I'm providing in the next few videos was run on a GPU with at least 16 gigabytes of memory, right? So if you go with a lower one than that, maybe like 12 or 8 or something, the tests and benchmarks might actually fail on you potentially. But so that's the main criteria I go on. I also just choose my own consonants in the hopes that, oh, maybe they'll be faster and more reliable just by proximity. I don't actually know. Price increasing, therefore cheapest up top. And one GPU, this shouldn't actually matter if you look at the cheap prices, but I always select one GPU. The cheapest options are not always the best. You can see there's an actual metric as to how good a GPU is. It's right here. We have a 6.5. I'm actually make my screen bigger here. 6.5 in deep learning performance. This is a proprietary metric that Vast AI has to measure GPUs and how fast they are. I'm usually more concerned in terms of testing kernels with how much RAM they have personally, but whatever. And what I usually get is actually this one right here. It's a 4060 Ti out of Kentucky. I've almost always used this person's GPU. It's usually available, and it's 13 cents an hour or 12.8 cents an hour, right? Very, very simple. And so what does that come out to? It takes me like 10 hours or something to spend $1.28 is what the actual cost is. So this is a very cheap thing to do in terms of just testing your ability to write GPU kernels. Obviously, if you do want to go train a model or something, you might need to switch to like the 8 GPU nodes, in which case, oh, you can grab 8 GPUs actually all together hooked up to each other, which are way faster and better for training, obviously. I will also say, in my experience, you do want to use a GPU that is sufficiently new, at least for Triton. I could be wrong on here, but as to why this is happening, but I have had it happen that the exact same Triton code, uh, gives incorrect values on an older GPU and correct values on a newer GPU. I have had that happen before, a couple times at this point, and I could be wrong as to why it's happening. I think it's a bug in Triton rather than a bug with the GPU, because any GPU's flop should be the same, I think. But I tend to steer away from these Tesla ones. What you can do is you can look up 4060 Ti, right? And what I look for is GPUs that are Ampere and newer. If you look up Ampere, Ampere, Ampere GPU list, these are GPUs that were roughly 2020 to 2024, I want to say, out of NVIDIA. But like Google says right here, examples are the RTX 30 series, 30, 60, 70, 80, 90. The A100 is a very popular GPU to use for AI research. Very, very popular, stuff like that, right? We can go, there's newer ones, obviously. Are we on Hopper right now? I think we're on Hopper right now, but I'm not quite sure. For example, the H100, I think the 40 series of GPUs are also Ampere, but I could be wrong. But what I usually use is a 4060 Ti. Just make sure the GPU came out in like 2020 or earlier, and you'll probably avoid what I'm worried about, but maybe it's not an issue for you. I don't know. If you know the reasons why that happens, let me know in the comments down below. But I've had the exact same code break on an older GPU. Anyways, tangent aside, once you find the GPU that you want, I just hit rent. Of course, I've already made an account and added my billing information and everything, obviously. That's all already done. And I go to instances on the left, and it is sitting here creating my instance. This may take a few minutes. If it takes too long, I just destroy my instance and I say that person's not very helpful right now. It's not going to work. Here we go. Now it looks like it's probably live. And you can, if you know how to SSH into something, you can go ahead and do that. I actually usually do that, and I usually work in VS Code. In future videos, you'll see me doing that, but I don't feel like teaching how to do that here. It's a very off-topic thing. What you can do instead is you can just connect directly via Jupyter on your internet browser. There's a little Jupyter button in this bottom right part of the box right here. On Safari, at least, you do have to progress, even though it's not private. And here you end up with, you are now on that person's computer, right? Like you're now sitting there. And then to get the actual GPU prepared, what I do is I go up to File, New Terminal, and there's a pop-up window usually, but it's just a separate window. And then these Vast AI GPUs, it varies by GPU provider. The Vast AI ones tend to not have everything installed, whereas Lambda, for example, is usually pretty up-to-date in all of its installations. So what I do first is I do sudo sudo apt apt update. If you already know Linux, well, this shouldn't be a tutorial. You should be skipping past this, honestly. But for those of you who don't know Linux, like I'm on a Mac right now, right? And then the next command I do is sudo apt install build dash essential. Build dash essential. And then it wants to ask me if I want to continue or not. So I click the letter Y and hit enter. This is just setting up basic things that their Linux environment should have. And a lot of underneath stuff you don't want to deal with would break if you didn't install this. I frequently have, before I was doing this, Vast AI GPUs would occasionally break if I did not do sudo apt update, sudo apt install build essential, right? Next thing is you want to be able to actually access whatever code you already have written, likely from GitHub, as well as upload that code back to GitHub when you're done, right? So we do sudo apt install gh. Then once that's installed, we say gh auth, meaning auth, and then login. And then you just hit enter a few times basically, but first it's saying what account do you want to log into? GitHub.com, that's the one I want to do. So I hit enter, and then preferred protocol for Git operations. I actually do use SSH usually, but let's just HTTPS is easier for actually logging the web browser. So we hit enter again, and then authenticate Git with your GitHub credentials. I hit the letter Y and then enter as well. And now it's saying, how do you want to authenticate? Like, do you want to use a web browser or paste in a token? Web browser is easier for me anyways. I hit enter once again. And then it gives you a code that you have to copy. So Command C on that. And then I hit enter once again, and that will open GitHub in my browser. Oops, didn't actually work. Usually on VS Code, it opens up my browser. It knows what to do, but here it's not working. So instead it provides an actual code of just, you could type it in, but I'm gonna just click this actual GitHub link. It's github.com/login/device. And then my computer, I am already signed into GitHub. Perfect. If you're not, go ahead and do that, I guess. But then I say continue. And then it wants that code that I copied, just paste that in there. And again, authorize GitHub to do all the things from this remote computer and use passkey. At this point, if you don't have a passkey set up, I believe GitHub will have you log in with your actual password or something. I'm not quite sure anymore, honestly. There's also, yeah, you can use the Authenticator app instead or use your password. My computer has a passkey set up. I'm just gonna go ahead and use that, but you can go ahead and use your password if you'd like. Use passkey, and then it's mine just Apple passkey. Hit continue, and I'm all set. So I can now close out of this window, and you can see here, authentication complete. Press enter to continue. I'm gonna hit enter. Fantastic. And now we can do things like clone a specific GitHub repo. So I'm gonna actually, in a new tab, open up GitHub again, just regular GitHub homepage, and I'm gonna go to one of my repos. Actually, I'm gonna go to the one that we're using in this tutorial series, of course, which is evantunador/Triton_docs_tutorials. The version you're seeing right now is out of date by the time you watch this video. It'll have more, it'll look different from this. But basically, I want to clone this repo. Usually, if you have Git installed, at least however I have installed on my Mac, usually, I would need to have the SSH code and everything. But actually, in here, all I've had to do with this GH is I do GH repo clone and then my username. So evantunador/Triton docs tutorials. Now, presumably, if you don't want to work with my repo directly, you want to actually fork it for yourself or something, go use your own version, that kind of thing. But I'm going to use mine. So GitHub, your GH repo clone, evantunador/Triton docs tutorials, and then you would have your own, replace my username with your own type thing if you forked my my repo. Enter, and then it clones that repo, and we can now go back to our other original tab that had the Jupyter lab in it, and it doesn't seem to be showing. Oh, actually, okay, I had to hit refresh, but it now does show the folder Triton docs tutorials, and you can see in here is the whole repo. What you also have to do if you want to take any updates that you make, any code you write, and you want to push them, is git config -- global user.name evantunador in my case, and git config -- global user.email evantunador@gmail.com. That is public, thank God, but your email, right? And so you can now set your username and email, but you're actually still logged in because you already logged in earlier, right? This just sets in your local environment what the computer thinks your username and email are. Boom. And then now we should be able to make any change to that repo as well as run its code. And the last thing I do for actual my repo, right? Generally speaking, usually you should use a virtual environment for everything you do. I've been pretty lazy with the project because I know that I'm going to just not use the cloud GPU again and it'll all get deleted anyways. I've been not using virtual environments at all. If you want to use one, go ahead. I have not been because it's not my local computer or anything. And I just do pip install, and then my repo, I believe, demands, I should update my requirements file. I'm going to have that all finished once you open everything up kind of thing, once the videos are all up. But pip install, I believe I had numpy, matplotlib, pandas, torch, Triton, and I think I also had pytest being used at some point. We're going to install those. In a second, we're going to actually also install, just force an update to PyTorch and Triton, right? So pip install -- upgrade torch. This is important to do because in my experience, Triton can be kind of buggy, and the newest version is a good bit better. So this right now is just making sure we're not using whatever was cached, but we're actually upgrading to the newest version of PyTorch. And we got an error, but it was just with Torch Audio and Vision, and I don't really care about those at all for this purpose. And I'm going to do the same thing with pip install -- upgrade Triton. I believe it's already in a good Triton version. 3.2 is roughly the newest, but let's just make sure. Yep, all good. Now it's all set up, and we're going to use this window, I suppose, for running any scripts. And here you can see, you can go into your code. And if you had Jupyter notebooks, that'd be great. If not, we can go in and edit any given code inside our Jupyter notebook setup and then run it as usual from our terminal right here. And that's how you get it set up with an actual GPU. Let's some little tips to see your GPU and everything. I do watch -N1 NVIDIA -SMI, and this allows you to actually see your GPU and all of its utilization. You can see the fan temperature or percent speed or something or other right here. GPU fan percent speed. There's the temperature right here, 40 degrees Celsius. The name of your GPU, the watts it's actually consuming out of its total maximum allowed possible watts, right? You can see right here how much memory it's using out of its maximum. 2 megabytes is your default, like it's just doing nothing. And then your GPU utilization. This is not volatile GPU utilization. It's actually just GPU util. This thing up here is its own phrase that is separate from this. I wish they phrased that better. But basically, what you want running a kernel is you want 98, 99, 100% to actually be this number whenever your kernel is running a lot. Of course, when you actually hit run of the code, there's gonna be like a second of it being zero. Then it'll go up and down while it messes with things potentially. But hopefully, when running a full model, when you're multiple iterations through, you should be seeing, ideally, if you've written your code all very well, a very high number right there, 99% type thing, right? And then down here, it shows the actual different processes running on your GPU. I found that with Vast AI, there is some kind of bug in the environment. It doesn't actually show anything. It just always stays stuck right here. But with a working instance, you should be able to see the actual ID of any instance, as well as how much memory that specific PID is using. When it says PID right here, it does not mean the same thing as what I say when I mean PID in our future lessons, but keep that in mind. Preferably, if I find a way to fix this, I'm gonna leave the comments down below, but you do want to have this bottom piece working, even though it does not work on Vast AI. I'm assuming other GPU providers are gonna have it work just fine, I would assume. I'm gonna try and fix it on Vast AI, but because sometimes if you really mess up your code, you might end up with a GPU kernel that just keeps running and doesn't stop, which is less common than with regular code. There's not very many common while loops or anything in GPU kernels. They do exist though, they are there. And you want to be able to use this PID to end the process if necessary, preferably, right? But so this is the window that lets you see all that. The watch-N1 piece made sure we refreshed every second. If you don't do that, then it'll be a static reading that just sits there and doesn't actually help you because it's just from like seconds ago. Whereas this is updating every single second right here. And then you can go ahead and yeah, code GPU kernels to your heart's content. Again, I usually, for the remainder of this series, I'm going to be working in VS Code, so I'm not actually using JupyterLab. I'm going to SSH into it, so VS Code works. But I don't feel like teaching y'all how to SSH into something. Go ask ChatGPT how to do that. It'll help you out with all of your hash ID, key, whatever they're called, and all that stuff. But yeah, end of video.